Ang ating kailangan malaman is the formula for the Henderson-Hasselbalch equation. So the formula here, as what we can recall, is pH is equal to the pKa plus the log of bicarbonate over carbonic acid. No? Again, ulitin ko po. No? So pH is equal to pKa. Sensya na po, wala po kasi akong ways para masulatan. Wala po akong Apple pen or to jot here sa presentation. So pH is equal to the pKa plus the log of your bicarbonate or the conjugate base or the salt over the acid, no, carbonic acid. Okay? Wherein yung ating pong pK, so that is letter D, no? Wherein the pKa po is a constant of 6.1 plus the log nga po of bicarbonate over carbonic acid. Kapag hindi po binigay yung carbonic acid, we can compute carbonic acid by multiplying your partial carbon dioxide times 0.03. So for us to compute for the carbonic acid, we can multiply PCO2 or partial carbon dioxide times 0.03. Kapag hindi naman po binigay si bicarbonate, we can obtain your bicarbonate by subtracting carbonic acid from total CO2. Kasi po yung total carbon dioxide or total CO2 is a sum or is equal to bicarbonate plus carbonic acid, wherein majority of the carbon dioxide in our circulation is in the form of bicarbonate. So for us to measure bicarbonate, so simply we have total CO2 minus carbonic acid. Okay? So again, for pH computation, so pH is equal to 6.1 plus the log nga po of bicarbonate over carbonic acid. For us to compute for the carbonic acid, madali lang, PCO2 times 0.03. For us to compute for the bicarbonate nga po, we can have total CO2 minus carbonic acid. Total CO2 minus carbonic acid. And again, kapag hindi nga po binigay yung carbonic acid, we can have total CO2 minus open parenthesis PCO2 times 0.03. Okay? So, yun po yung pwede nating extended na formula po doon. Okay, for example, in this problem, no, if the pKa nga po is 6.1, the CO2 content, so CO2 is the total CO2 is 25, the salt equals and the total CO2 minus the carbonic acid. So the bicarbonate nga po is equal to total CO2 minus carbonic acid. And the carbonic acid is equal to PCO2 times 0.03, while the PCO2 here is 40 mm mercury. So it may be concluded that okay, so try po natin isolve. So pH is equal to 6.1, that's for the pKa, plus the log. So ang ating pong numerator is the bicarbonate, ang ating denominator is carbonic acid. And carbonic acid nga po can be computed by multiplying your PCO2, which is 40 here, times 0.03, while for the numerator, that's total CO2, so that would be 25 minus your carbonic acid. And again, carbonic acid can be computed by multiplying your PCO2 40 times 0.03. Okay? So simply, pH is equal to 6.1 plus the log of your, so yung ating pong denominator is 40 times 0.03, so that is 1.2. Okay? That is 1.2. And then, sa atin naman pong numerator, that is 25 minus carbonic acid nga po is 40 times 0.03. That is, again, 1.2. So, basically, we have pH is equal to 6.1 plus the log of 25 minus 1.2 over 1.2. So, that is letter C. Tama? Nakuha po yun? Okay, try nga po, let's continue solving for the pH, no? Kung magutugma po tayo. So, pH equal to 6 is equal to 6.1 plus the log nga po of your bicarbonate over carbonic acid. Carbonic acid is computed by multiplying PCO2 times 0.03. So that is 1.2 nga po. No? 40 times 0.03 is 1.2. And for the numerator, we have, to compute for the bicarbonate, we have your total CO2, which is 25, minus carbonic acid. And again, carbonic acid is computed as PCO2 times 0.03. So 40 times 0.03 is 1.2. So minus 1.2. Tama? Yan po yung given natin sa letter C. Continue lang po natin yan. pH equal to 6.1 plus the log of 25 minus 1.2 is 23.8 over 1.2. So 23.8 divided by 1.2. So the log of that plus 6.1. So the pH is 7.397 or basically 7.40. Okay? Na-compute po ba yun? Double check ko lang po. Oh. So we have, tama, 7.397395 or basically 7.40. Okay, so pH equals 7.40. Okay, isa pa po, no? Compute po ulit tayo. Calculate the blood pH given a PCO2 of 60 mm mercury and a bicarbonate of 18 millimoles per liter. Okay, so sabayan ko po kayo. So pH is equal to the pKa, which is 6.1, tama? Plus the log, numerator is bicarbonate. So binigay po dyan si bicarbonate, which is 18 over carbonic acid. Carbonic acid can be computed nga po by multiplying PCO2 times 0.03. So 60 times 0.03. Okay, so pH is equal to 6.1 plus the log of 18 over, ilan po yung 60 times 0.03 is 1.8. Okay, so the log of 18 divided by 1.8, then plus 6.1, so that is, the pH here is 7.1. Okay, or 7.10. So we have letter C. Nakuha po ba yun? So we have letter C, 7.1 or 7.10. Okay, next po tayo. The reference range for the pH of arterial blood measured at 37 degrees centigrade is. So, kailangan po syempre alam natin yung reference values natin for this. No? So, for the arterial blood pH, the reference value is 7.35 to 7.45. Again, the reference value is 7.35 to 7.45. Tama? So, we have letter C, 7.35 to 7.45 arterial blood pH. Ano pa yung mga kailangan tandaan aside from the pH here? So, we have your PCO2. So, the PCO2 is 35 to 45 as what we can see here, millimeter mercury, no? Madali lang po yan. Tandaan nyo lang po yung 35 to 45, no? So, 35 to 45 millimeter mercury. And then for bicarbonate naman, we have 22 to 26 millimoles per liter. Yung total CO2 hindi kakalayo sa ating bicarbonate because the majority naman po ng form ng carbon dioxide sa blood is in the form of bicarbonate. So total CO2 is basically bicarbonate plus carbonic acid. So 23 plus 20 23 to 27 naman po. So, nag-add lang tayo doon, no? Millimoles per liter. And then, for PO2 naman, we have 80 to 100 millimeter mercury. Okay? And then, for oxygen saturation, we have 94 to 100%. Okay? So, again, that's for your reference values. Okay? So, again, review nga po tayo. Reference value for pH, 7.35 to 7.45. Paano naman yung PCO2? 35 to 45. Paano naman po yung bicarbonate? 22 to 26. Either millimoles per liter or milli equivalent per liter. So, ganun. Okay, and we can use this one nga po no, to assess kung acidosis or alkalosis. Siyempre, kapag less than 7.35 ang pH, that is acidosis. Kapag more than 7.45, that is a case of alkalosis. No? But we have two types. We have respiratory at saka metabolic. So, kapag PCO2, this one is used to assess respiratory. No? So, kapag mababa ang PCO2, that is respiratory alkalosis. No? Pag mataas naman ang PCO2, respiratory acidosis. No? Isipin nyo yung CO2 acidic. No? So, less than 35, respiratory alkalosis. More than 45, respiratory acidosis. Sa bicarbonate naman, kapag mababa ang bicarbonate naman po is used to assess metabolic condition. So, kidney naman po. No? So, for less than 22, that is metabolic acidosis. Pag more than 26 naman po, metabolic alkalosis. Okay, so we have respiratory acidosis, alkalosis, metabolic acidosis, metabolic alkalosis. No? Tapos we also have a concept of uncompensated and partially compensated and fully compensated. When we say po uncompensated, hindi pa niko-compensate si kidney o kaya si lungs. No? So yung PCO2 or bicarbonate na counterpart hindi pa nag-a-adjust no, dun sa condition. While kapag partially compensated na po yun, kailangan yung isa nag-compensate na. No? And then kapag fully compensated na po yun, dapat nag-normal na yung blood pH. So yun po yung ating indicator for full compensation. Okay. At a blood pH of 7.4, what is the ratio of bicarbonate to carbonic acid? So, kapag ang blood pH po ay 7.4, ang ating pong automatic na bicarbonate to carbonic acid ratio is 20:1. So, ibig sabihin po, kapag 20:1 yung ratio ng bicarbonate to carbonic acid, automatic po na ang blood pH na ay 7.4. Okay? So the expected blood gas result for a patient in chronic renal failure would match the pattern of, so for chronic renal failure, so this one is an example of metabolic acidosis, no? Metabolic acidosis. Okay? Ano nga po ulit kapag metabolic acidosis? Mababa si bicarbonate less than 22. Kapag metabolic alkalosis, the bicarbonate is more than 26. Paano kapag respiratory acidosis, mataas si PCO2, more than 45? Paano kapag respiratory alkalosis, mababa si PCO2, less than 35, no? Respiratory acidosis more than 45, PCO2 level, respiratory alkalosis naman is less than 35, no? So again, metabolic acidosis, bicarbonate is less than 22 millimoles or milliequivalent per liter. Metabolic alkalosis, the bicarbonate is more than 26 milliequivalent per liter or millimoles per liter. Kapag respiratory acidosis naman po, PCO2 yan, no? So the PCO2 is more than 45 millimeter mercury, while for respiratory alkalosis, the PCO2 level is less than 35, no, millimeter mercury. Okay, so ano po yung mga common example? So, start tayo sa metabolic acidosis. Aside from renal failure, ano pa? Palisa na lang po ako. We have bicarbonate deficiency. Of course, no, kasi nga, bicarbonate is less than 22. So, bicarbonate deficiency, metabolic acidosis talaga yon, no? Ano pa? Diabetic ketoacidosis, no? Lactic acidosis, no? Ano pa? We have renal failure, as what we said here, and diarrhea. So, diarrhea din po is a case of metabolic acidosis. Okay, so metabolic acidosis. Pakitake note din po ng salicylate poisoning or aspirin overdose. So, again, aspirin po is acetyl salicylic acid. So, yun din po yun, no? So, salicylate poisoning is aspirin overdose. So, sa case po ng salicylate poisoning, sa una, respiratory alkalosis po siya. And then, it will develop later on to become metabolic acidosis. So, dalawang condition sa kanya. Una, respiratory alkalosis. And then, sa latter stage, magiging metabolic acidosis. Okay, ano naman po yung common example ng metabolic alkalosis? So, yun naman po ay kapag meron kang excess bicarbonate, no? Pag may metabolic alkalosis o kaya decrease in acidity such as in case of vomiting. So, vomiting can cause metabolic alkalosis. Okay, ano naman po yung example ng respiratory acidosis? So, respiratory acidosis naman po, ibig sabihin, nag-accumulate nga po yung partial carbon dioxide o yung CO2 sa atin, no? Leading nga po to respiratory acidosis. So, example po niyan kapag may case nga ng hypoventilation. Okay? Kaya nag-accumulate si carbon dioxide resulting to respiratory acidosis. So, hypoventilation. So, example, we have COPD, chronic obstructive pulmonary disease, which is common among smokers. Kaya pag smokers nga po at nagkakaroon ng respiratory acidosis. So again, we have your chronic obstructive pulmonary disease. Aside from COPD, we also have pag may emphysema, COPD, we have mga common pneumonia, no? So pneumonia din po can cause respiratory acidosis. We also have yung pag nag-intake tayo ng mga morphine, yung mga downers, no? Morphine, barbiturates, mga opiates. So it can result nga po to respiratory acidosis because of hypoventilation. Next, we also have respiratory alkalosis. Sa case naman po ng respiratory alkalosis, then may case naman ng hyperventilation resulting to low PCO2 kasi nag-hyperventilate, no, resulting to low PCO2. So, respiratory alkalosis. Ano po example niyan ng mga hyperventilation? Anxiety, asthma, and again, di ba we said kanina, no, salicylate poisoning or aspirin overdose sa una, respiratory alkalosis, and then it will progress to metabolic acidosis. Okay? Tapos tandaan din po yung mga compensatory mechanism. Alam po kapag uncompensated, partially compensated, at saka fully compensated. Okay. So in this one, a 68-year-old man arrives. Clear po ba doon, no? Sa difference ng mga different ng mga conditions, no? Metabolic acidosis, metabolic alkalosis, respiratory acidosis, and respiratory alkalosis. Okay. A 68-year-old man arrives in the emergency room with a glucose level of 722 milligrams per deciliter and serum acetone of 4 plus undiluted. Okay, so there is already a case nga po of diabetic ketoacidosis, di ba? And sa case nga po ng diabetic ketoacidosis, so there is metabolic acidosis, so there is a low pH. A low pH and a low bicarbonate less than 22 yung ating ine-expect dito sa kay case ng diabetic ketoacidosis. Next, the following blood gas results were obtained. So the patient results are compatible with which of the following? So the pH here is 7.18. So there is a case of acidosis. No? Tapos, the PCO2 here, so unang lagi mo titingnan ay yung pH. Ngayon, kailangan mong hanapin kung ang nag-cause ba ay PCO2 or bicarbonate dun sa pH na na-develop. So again, nagkaroon nga po dito ng acidosis. So the PCO2 here is 60. Again, the normal PCO2 ranges from 35 to 45. So there is high PCO2 that resulting nga po to a low pH. Dito po yung kanyang bicarbonate is in a normal value of 22 to 26. No? So again, a case po of respiratory acidosis. No? So high PCO2, low pH, so respiratory acidosis. And that is because of hypoventilation such as emphysema, no? Pneumonia, COPD, yung mga ganyan. No? So we have letter C, emphysema. No? And so in case of emphysema po, there is fluid accumulation in the alveolar spaces resulting to hypoventilation, respiratory acidosis, so a high PCO2 accumulation, and then a low pH. Okay? Clear po doon? Okay, which set of result is consistent with uncompensated respiratory alkalosis? So, unang titingnan, kailangan alkalosis. Unang-una titingnan pH muna. So, alkalosis here is letter A or B. So, you are left with A or B, no? For alkalosis. Because the normal or the reference value for pH is 7.35 to 7.45. Okay, so A or B. Okay, and then after po nun, kailangan hanapin mo yung respiratory yung cause, no? So kailangan the PCO2 here is low, no? Less than less than 35, no? So less than 35 yung PCO2. So pareho sila, no? So pareho less than 35 yung PCO2. So and then the next mo kailangan gawin is kailangan po yung uncompensated. So, 'di ba, the compensatory mechanism for respiratory alkalosis, so dapat the liver will compensate by lowering the bicarbonate, no? By lowering the bicarbonate, no? So kapag tama kasi kailangan magkaroon ng acidosis, no? So kailangan mag-lower yung bicarbonate, no? To counter yung alkalosis dito. So in that case, pero kapag uncompensated po yun, kailangan kailangan normal lang si bicarbonate dito, no? Okay, so in that case, the normal bicarbonate ranges from 22 to 26. Tama? So the answer here is letter B. Okay? Nakuha po ba yun? No? So again, anong step na ginawa natin? Una, yung pH muna. Hanapin natin yung alkalosis. Kailangan mong hanapin ngayon kung saan yung respiratory dito. No? So kailangan mong hanapin yung respiratory. So again, PCO2, yung cause dapat kung bakit nagkaroon ng ganong pH. No? And then after nun, so in that case nga, alkalosis, so kailangan kung respiratory alkalosis po mababa or less than 35 ang PCO2. No? So again, kaya important po dito malaman natin yung reference values. No? And then kung yun po ay uncompensated, kailangan normal po ang bicarbonate. So dapat within range siya na 22 to 26. Okay, so that's letter B. Yung letter A po actually, alkalosis siya. Tapos mataas si bicarbonate, tapos mababa si PCO2. So para siyang hindi ka sigurado ngayon dito sa letter A kung siya ba ay respiratory or metabolic alkalosis. No? Kasi this one is a case of metabolic alkalosis. And ito naman ay case ng respiratory alkalosis. No? So, pero merong case ng alkalosis. Okay? Yung letter B naman is uncompensated respiratory alkalosis. Kailan po siya magiging partially compensated? Magiging partially compensated ito kapag si bicarbonate ay nagkaroon na ng value na less than 22. No? So, kapag less than 22 na yung level ni bicarbonate. Okay? For example, naging 15, 10, gano'n. No? So, nagkakaroon siya ng compensation. Partially compensated respiratory alkalosis na po yun. No? Kapag ang bicarbonate is nag-compensate na. No? Nagkaroon na ng less than 22, no, bicarbonate value. That is partially compensated. Kapag fully compensated na po yun, dapat ay normal na si pH. Clear po ba yun? No? For the application nga po ng mga ganitong measurement, no, for acid-base balance. Okay? Next po tayo. Okay, so for blood gas measurement po natin, the specimen for blood gas determination should be drawn into a syringe containing, alam niyo po ito, we have letter B, heparin. No? So we are using here lithium heparin. So kailangan po pre-coated na yung syringe ng lithium heparin. Okay? Again, pakitandaan, we are not using evacuated tube, no? And we are never using evacuated tube for blood gas determination. So we are using a pre-coated syringe with heparin or a syringe pre-coated with heparin. Okay? Pero one of the common din po na error kapag nasobrahan naman si heparin because excess of heparin can also lead to false result. Ano po nangyayari doon? Nagkakaroon tayo ng false increase ng PCO2, nagkakaroon tayo ng false decrease ng pH at saka false decrease ng PO2. Okay? Tandaan niyo po no, na ang PCO2 laging inverse niya ang pH. Tapos ang pH naman sa PO2 laging direct ang kanilang relationship. So ibig sabihin, kapag mataas si PCO2, mababa si pH, mababa si PO2. Kapag mababa si PCO2, mataas si pH, mataas si PO2. Okay, again, ulitin ko po yun. Ang PCO2 inverse sa pH, which makes sense, di ba? Kasi higher CO2, acidic, low pH. Tama? So, tapos ang pH naman, direct naman sa PO2. So, high PCO2, low pH, low PO2. Okay? Kapag mababa naman si PCO2, mataas naman si pH, mataas naman si PO2. Nakuha po yun. So, that's the relationship always. No? So, again, kapag nasobrahan nga po sa heparin, ano nga po mangyayari? False increase ang PCO2, false decrease ang pH, false decrease ang PO2. Okay? Tapos, kailangan po, for blood gas measurement, dapat the sample should be under a or in a chilled temperature, so in ice, siya nakalagay, or chilled water during transport, and it should be tested within 30 minutes or less than 30 minutes. Kapag hindi po nagawa yon, ibig sabihin hindi mo nalagay sa ice, hindi siya nagawa within 30 minutes, ang mangyayari, magkakaroon tayo ng false increase PCO2, false decrease pH, false decrease PO2. Yung parang kanina lang din, no? False increase PCO2, false decrease pH, false decrease PO2. Okay? So, yun naman po yung mangyayari doon. Okay? Again, ito po ay bawal ma-expose sa air because exposure to air, syempre, will increase the PO2 and decrease the PCO2. Okay? Okay. So, unless blood gas measurements are made immediately after sampling, in vitro glycolysis of the blood causes. So, again, no, parang ito rin po yung hindi mo kaagad na process nga yung specimen, hindi nga siya nagawa within 15 minutes, hindi nga siya nalagay sa chilled water. Ano mangyari ulit? Increase ang PCO2, decrease ang pH, decrease ang PO2. Okay? So we have rise in PCO2, so that is A, B, or D, tama? Tapos there should be a low pH. So, hindi na pwedeng letter A kasi rise in pH yan. Yung letter B naman kasi dapat kung fall in pH, dapat fall din yon sa PO2. So, mali din po yun. Yung letter C naman, dapat there should be low pH nga, not rise in pH. So, mali po yun. So, we have letter D. Tama? So, again, there is, kapag hindi nga po na-process yung specimen, high PCO2, low pH, low PO2. Tama? So, high PCO2, low pH, and low PO2. Okay? So, we have letter D. Okay? So, high PCO2 or rise in PCO2, low pH, low PO2. Yung ating na-expect na false result dito. Okay? So, again, always take note of the relationship. Okay? So, again, PCO2 is inverse of pH. pH is direct of PO2. Kapag mataas si PCO2, mababa si pH, mababa si PO2. Kapag mababa si PCO2, mataas si pH, mataas naman si PO2. Okay? Tapos tandaan po ulit yung ating mga reference ranges. Tandaan po yung mga different condition ng metabolic acidosis, metabolic alkalosis, respiratory acidosis, respiratory alkalosis, and then yung concept nga ng uncompensated, partially compensated, saka fully compensated. Okay. Next po tayo. At tapos again, we are collecting for blood gas. Kailangan nga po syringe ang ating ginagamit or that is pre-coated nga po with lithium heparin. Okay, an arterial blood specimen submitted for blood gas analysis was obtained at 8:30 a.m. but was not received in the laboratory until 11 a.m. O sobra-sobra na yung oras, no? The technologist should, letter D, request a new arterial specimen be obtained. Okay? So, kahit naka-ice water pa yon, hindi mo na pa rin tanggapin yan. Okay? Kasi dapat within 30 minutes. Okay, so request a new RTL specimen be obtained and dapat i-follow na dapat yung time at saka yung specimen transport. So chilled water within 30 minutes dapat ma-process yung specimen. Okay, a blood gas sample was sent to the lab on ice and a bubble was present in the syringe. Yun nga lang, no? Tama nga, nasa ice pero may presence naman ng bubble. The blood had been exposed to room air for at least 30 minutes. The following change in blood gases will occur. Siyempre, kapag na-expose siya sa air, kung may bubbles na-expose sa air, increase ang PO2. Okay, increase ang PO2. Tapos, increase ang PO2 and decrease ang PCO2. So, increase ang PO2, decrease ang PCO2. Okay? So, decrease ang PCO2. And we can also say na decrease din dito ang carbon dioxide, no? Kasi the major carbon dioxide content nga in the or in the major CO2 present in the blood is in the form of bicarbonate. So, mataas ang oxygen, mataas ang PO2, pero mababa ang carbon dioxide. So, we have letter D. No? Increase ang PO2, decrease ang bicarbonate. Okay, syempre mababa dapat din ang carbon dioxide or bicarbonate nga po because the major form of carbon dioxide in the blood is bicarbonate. No? So, decrease nga po yan. Tapos, increase ang PO2. Okay? Kapag increase ang PO2, dapat increase din ang pH. Kasi direct ang kanilang relationship. Kaya mali yung letter C. Tama yun that the CO2 content and PCO2 is decreased, pero dapat pH is increased. Okay? Sa letter B naman, ang mali naman dito, tama yung pH is increased, pero dapat ang CO2 content saka PO2 ay decrease. Okay? Decreased. Nakuha po yun. Okay, clear po ba doon? Okay ha. Sa letter A naman, dapat the CO2 here is decreased. Okay? So, CO2 is decreased. Dapat PCO2 ay decreased. Dapat ang PO2 increased. Ang PO2 ay laging direct sa pH. Ang pH din dapat ay increased. And the bicarbonate here, just like your CO2 being decreased, so bicarbo is the major form of carbon dioxide in the blood, so bicarbonate is decreased. So, tama po dyan ay yung letter D. PO2 ay increase, PCO2 ay decrease, CO2 ay decrease, pH ay increased, bicarbonate ay decreased. So, yun po yung expected natin. Okay, kapag may presence nga ng oxygen. So, we have letter D. Or kapag na-expose sa air. Okay, arterial blood that is collected in a heparinized syringe but exposed to room air would be most consistent with the changes with which of the following specimen. So again, tandaan nyo po ulit yung ating relationship dito. No? So, mangyayari magkakaroon tayo ng increase ng PO2. No? So, increase ng PO2 and a decrease nga po ng PCO2 upon exposure to air. No? And again, ang pH po ay inverse ng PCO2. So, ang pH ay direct sa PO2. So, kung increase ang PO2, increase ang pH. Increase ang pH nga, decrease nga ang PCO2. So, dapat increase PO2. Okay? Dapat decrease PCO2 at dapat increase pH. So, we have specimen A. Okay? So, we have specimen A. Okay. Next, most automated blood gas analyzers directly measure. So again, most automated blood gas analyzers directly measure. So we are measuring nga po yung pH, we are measuring yung PCO2, at saka we are measuring your PO2. Okay, yung bicarbonate po, we are using na dyan yung mga we are computing bicarbonate by multiplying PCO2 times 0.03. Okay? Using yung ating Henderson-Hasselbalch equation. Okay, di ba? Bicarbonate, that's for carbonic acid pala. Carbonic acid is computed by multiplying PCO2 times 0.03, pero yung bicarbonate can be computed by total CO2 minus carbonic acid. Okay? So, for blood gas analyzers, ang ating directly na mini-measure, or we can compute nga bicarbonate by Henderson-Hasselbalch equation. Pero yung for automated blood gas analyzers, what we are measuring is the pH, the PCO2, and the PO2. Again, nalinawin ko po, yung mini-measure ng blood gas analyzers, pH, PCO2, at saka PO2. Yung bicarbonate po, pwede siyang makompute, diba? If we will go back to Henderson-Hasselbalch equation, total CO2 minus carbonic acid, which is PCO2 times 0.03. O kaya, we can compute in general dun sa Henderson-Hasselbalch equation, kailangan mo lang given na yung pH, no? Ang kailangan mo hanapin naman ngayon is yung bicarbonate. Parang gano'n. So we can compute, no? For the bicarbonate. Okay. Pag tinanong tayo, ano yung ating ginagamit for the calibration of blood gas analyzers, we are using 2 buffer with known pH and a constant temperature. Again, pa-take note po ako, for calibration of blood gas analyzers, we are using 2 buffers with known pH and constant temperature. Okay, so going po tayo to your pH, to your PCO2 at saka your PO2 electrode. Review po natin, no? So for pH at saka PCO2 electrode, ang principle po nila ay potentiometry. Ibig sabihin, what we are measuring here is voltage. While for PO2 naman, the principle is amperometry. Okay? Or amperometry polarography, wherein we are measuring naman po the current. Okay? So for pH, we are using your glass electrodes. Okay? And we are also using the reference electrode, silver chloride reference electrode, or your calomel electrode, mercury chloride, or HgCl2, or calomel electrode. Okay? So, yun po yung ating ginagamit na mga reference electrode for pH. So, what we are measuring in pH is, of course, diba, basic principle ng pH measurement, we are measuring the change in the hydrogen ion concentration. Okay. Yung PCO2 po naman, actually, is a modification of pH. So, nanggaling din po si PCO2 sa pH electrode. No? Kaya pareho sila ng principle, which is also potentiometry. Ang kinaibahan lang ni PCO2, nag-add tayo sa kanya ng semi-permeable membrane. So, nag-add tayo ng semi-permeable membrane dun sa PCO2 electrode. Para yung membrane na yon, what it can detect is only the carbon dioxide. Again, para what it can detect is only the carbon dioxide. Kasi nga for PCO2 measurement siya. No? Pero may buffer po yun, yung PCO2 electrode, that will convert the carbon dioxide to carbonic acid or H2CO3. And then the H2CO3 will dissociate to become hydrogen ion and bicarbonate. So sa dulo, ang ating mini-measure pa din sa PCO2 ay yung hydrogen ion, wherein again, we are measuring the change in the hydrogen ion concentration by measuring pH. Kaya pag tinanong tayo, ano yung mini-measure natin sa PCO2? The answer is pH. Okay? Which is, kung iisipin nyo nga naman, ang PCO2 ay nanggaling din talaga sa pH electrode. Kaya what we are measuring in PCO2 is pH. Pakitake note po yun ha. What we are measuring in PCO2 is actually the pH. Okay? Yung PO2 electrode naman po, so again, PCO2 is your Severing-House electrode. Yung PO2 naman, yan yung ating Clark electrode. Gumagamit po yan ng silver chloride anode. Okay? Again, kapag naribig nyo po yung silver chloride reference electrode, that is for pH. Pero kapag narinig nyo yung silver chloride anode at saka platinum cathode, that is for PO2. So, ang PO2, gumagamit yan ng silver chloride anode, and platinum cathode. Again na, pakitandaan po yun. So, calibration of blood gas analyzers, we have two buffers with known pH and constant temperature. Okay, so amperometry is the principle of the your PO2 electrode. Tama? So, PO2. Kasi yung pH sa PCO2 nakabase sa potentiometry. Okay. Hydrogen ion concentration, pH in the blood is usually determined by which of the following electrodes. Diba? For pH electrode, we are using the glass electrode. No? So we have letter B, glass. Okay? In a pH meter reference electrode. So sa pH po, so yung ating, so we are using the glass electrode, and then for the reference electrode, we are using your silver chloride, or your calomel or mercury chloride. So we have letter A, silver chloride, reference electrode for pH. Which blood gas electrode is composed of a semi-permeable membrane, a silver chloride reference electrode, and a glass electrode? So para din po siyang pH, no? Kasi ang pH, gumagamit ng glass electrode, gumagamit ng silver chloride reference electrode, pero ito po ay merong semi-permeable membrane. As I said nga po kanina, yung ating PCO2 is a modification of your pH. So, para din po siyang pH, gumagamit din siya ng glass electrode, gumagamit din siya ng silver chloride, pero dito nag-add tayo ng semi-permeable membrane for it to be selective to carbon dioxide. So, this one is true for letter C, PCO2. Okay, PCO2. Tapos kanina po, in-explain na po natin, no, yung principle nga po, no, dun sa ating PCO2 measurement, no, wherein for PCO2 nga po, electrode, since it is a modification of your pH, so at the reaction nga po, the carbon dioxide that is selected by the semi-permeable membrane will be converted to with a buffer to carbonic acid, and carbonic acid will dissociate to form your hydrogen ion and bicarbonate. So sa last part pa rin niya, ang ating mini-measure pa din ay yung hydrogen ion, and we measure hydrogen ion by measuring your pH. Okay, so again, we have your pH. So in a blood gas analyzer, the PCO2 electrode is usually a pH electrode immersed in a bicarbonate solution. The bicarbonate solution is separated from the sample by a semi-permeable membrane that is selective to your carbon dioxide. No? And then, when CO2 from the sample diffuse across the membrane, it dissolves, forming carbonic acid and thus lowering the pH. So again, what we are measuring here is at the end is also the pH. Okay? So pag tinanong tayo, the measurement of CO2 in the blood by means of a PCO2 electrode is dependent on the, so it is dependent on the letter B, change in pH, because of increased carbonic acid in the electrolyte surrounding the electrode. So what we are measuring is the change in pH pa rin. Okay? In the PCO2 electrode. Okay? An electrode that has a silver chloride anode and a platinum cathode. So again, pag narinig po yung silver chloride, kapag yun po ay reference electrode, that's for pH. Pero kapag silver chloride anode and a platinum cathode, that is for PO2. So we have letter C, PO2. Okay, so again, that's for your acid-base balance and for blood gas analysis, and the instrumentation for your PO2, pH, and PCO2 measurement. Okay, next we have your endocrinology.